Ever wondered how Amish barns stay warm without electricity? While you're running electric heaters and insulated fans, Amish farmers rely on methods perfected over 2 centuries. No power lines, no heating bills, just animal body heat, strategic design, and techniques that keep livestock alive when temperatures drop to minus 20 degrees. Method 1. Animal body heat management. Large animals generate remarkable amounts of heat. A single dairy cow produces approximately 1,500 BTUs per hour through normal metabolism, equivalent to a small space heater running continuously. A barn housing 20 cows generates 30,000 BTUs hourly from animal bodies alone. Amish farmers understand this and design winter management around maximizing this free heat source. Strategic animal placement concentrates heat-producing animals in core barn areas during winter. Dairy cows, which need milking twice daily anyway, occupy the warmest central sections. Horses, which tolerate cold well, get positioned in cooler areas near walls. Young calves needing most warmth get placed nearest to mature cows, benefiting from their substantial heat output. The concentration principle guides winter barn arrangement. Rather than spreading animals throughout available space, Amish farmers pack them closer together during coldest months. This isn't crowding, it's calculated density that allows animals to share body heat while maintaining adequate space for health and movement. The combined body heat of concentrated animals can raise barn temperatures 20 to 30 degrees above outside air. Bedding depth increases around highest heat-producing animals, creating insulation that traps their warmth at ground level where it benefits all animals. This creates warm zones within the barn where even vulnerable animals can thrive despite brutal outside conditions. Method 2. Deep bedding system. The deep bedding system provides both insulation and heat generation through biological processes. Farmers start with a base layer of straw several inches thick on barn floors. Rather than removing this bedding daily, they add fresh layers on top. Manure mixed with straw begins composting, a process that generates significant heat. Active composting bedding can reach temperatures of 100 to 120 degrees Fahrenheit, several inches below the surface. This creates warm flooring that prevents animals from losing body heat through their feet and belly. The composting process continues throughout winter as fresh manure and bedding layers are added, creating a constantly generating heat source that costs nothing beyond straw. The system requires regular attention. Every few days, farmers add fresh straw layers on top of soiled bedding. The layering must be sufficient to keep animals clean while allowing composting to continue beneath. Too little bedding and animals lie in manure. Too much and composting slows, reducing heat generation. Experienced farmers develop intuitive understanding of proper depth through years of practice. By spring, bedding depth might reach 12 to 18 inches. This accumulated material gets cleaned out after winter ends, providing rich compost for gardens and fields. The winter bedding pack thus serves three purposes: insulation from ground cold, heat generation through composting, and spring fertilizer production. Method 3. Barn design and orientation. Traditional Amish barn design incorporates passive heating principles developed over centuries. Barns face south when possible, maximizing solar gain through south-facing windows and doors during short winter days. Even minimal sunlight entering through openings provides heat and raises interior temperatures several degrees. The two-story barn design is deliberate thermal engineering. Hay lofts above animal areas serve as massive insulation blankets. Hay's loose structure traps air, creating effective insulation that prevents heat generated by animals below from escaping through the roof. A well-filled hayloft might contain 20 tons of insulation material that would cost thousands of dollars if purchased as modern insulation. Low ceilings in animal areas, typically 8 to 9 feet, keep heat concentrated where animals live rather than allowing it to rise into unused space. This differs from modern barns with high ceilings that look impressive but waste heat. Amish barns prioritize function over appearance, keeping ceilings just high enough for human work but low enough to retain animal-generated warmth. The bank barn design, built into hillsides, uses earth as insulation on one or more sides. The earth-backed walls stay warmer than exposed walls, reducing heat loss through those surfaces. Animals enter at ground level on the lower side, while hay storage occupies the upper level accessed from higher ground. Method 4. Strategic ventilation. Ventilation creates the most challenging balance in winter barn management, removing moisture and ammonia without losing precious heat. Too much ventilation and temperatures plunge, too little and humidity creates respiratory problems and freezes on cold surfaces. Ridge vents running along the barn peak allow warm, moist air to escape. Since warm air rises naturally, these vents need no power, they work through convection. The vents are sized carefully, large enough to allow moisture escape, but small enough to prevent excessive heat loss. Some Amish barns have adjustable ridge vents that can be partially closed during the coldest periods. Eave openings along barn walls provide air intake, drawing fresh air in low where animals breathe. This creates natural circulation. Fresh air enters low, warms as it rises past animals, picks up moisture and ammonia, and exits through ridge vents. The system runs continuously without electricity, powered entirely by temperature differences between inside and outside air. Winter ventilation rates are carefully reduced compared to summer. Farmers might partially block eave openings during extreme cold, accepting slightly higher humidity to prevent dangerous temperature drops. They monitor frost formation on walls and ceilings. Excessive frost indicates too much moisture, requiring increased ventilation despite cold. Method 5. Banked walls with earth. Banking barn walls with earth provides natural insulation that reduces heat loss through exposed wall surfaces. Each fall, farmers pile soil against barn walls, creating earthen berms 2 to 3 feet high, extending several feet from the building. This banking uses the earth's natural insulation properties while costing nothing beyond labor. The earth banking typically happens on north and west walls, where prevailing winter winds strike hardest. South walls receive less banking to allow solar gain through windows. The banked earth must be sloped away from the barn to prevent water from pooling against walls and seeping into the barn interior. Snow accumulation against banked walls provides additional insulation. Rather than removing snow from around the barn, Amish farmers often leave it, recognizing that snow acts as excellent insulation. The combination of earth banking and snow accumulation can create insulation values equivalent to several inches of modern, rigid foam insulation. Spring requires removing the banking to allow walls to dry and receive maintenance. The earth gets spread on gardens or fields, enriched with whatever manure and organic matter it absorbed during winter. The banking cycle repeats annually, a labor-intensive process that modern farmers avoid, but Amish farmers consider essential. Method 6. Windbreaks and positioning. Wind dramatically increases heat loss from barns. A barn in open wind might lose twice as much heat as the same barn protected by windbreaks. Amish farmers understand this and plant tree lines specifically to block prevailing winter winds, typically from north and west. Evergreen trees provide year-round wind protection. Planted in multiple rows, 50 to 100 feet from barns, these windbreaks reduce wind speed by up to 80% on the sheltered side. The protected zone extends roughly 10 times the tree height. A 30-foot evergreen windbreak protects an area 300 feet beyond it. Strategic building placement uses natural landscape features for wind protection. Barns built on hillsides use the hill itself as wind shelter. Barns positioned near existing woodlots benefit from natural windbreaks. These permanent landscape features provide protection that improves as trees mature over decades. The windbreak benefits extend beyond heat conservation. Reduced wind means less snow accumulation around barn entrances and less drifting into barn interiors when doors open. Animals venturing outside for water or brief exercise face less brutal conditions in wind-protected areas. Method 7. Hay and straw insulation. Beyond the hayloft above animals, additional hay and straw get used strategically for insulation throughout the barn. Hay bales get stacked along interior walls, creating dead air space between the bales and walls. This simple technique adds significant insulation value while using material the farmer already possesses. Straw less valuable as feed than hay gets packed into wall cavities in older barns or stacked against exterior walls of newer buildings. The hollow stems of straw trap air effectively, creating insulation that prevents heat loss through walls. Some farmers stuff straw into gaps around doors and windows, sealing air leaks that would otherwise bleed precious heat. The loft hay serves triple duty: feed storage, insulation, and future income from hay sales. As hay gets used for feeding throughout winter, the insulation layer thins, but this happens gradually and coincides with warming spring temperatures when insulation matters less. The system is self-adjusting maximum insulation when hayloft is full in early winter, decreasing insulation as spring approaches and external temperatures moderate. Replacement happens annually. As winter hay gets consumed and spring arrives, new hay from the coming summer's harvest will refill the loft, restoring insulation for next winter. This annual cycle has operated unchanged for generations, proving both effective and sustainable. Method 8. Concrete floors with drainage. Proper flooring prevents moisture problems that undermine all other barn warming efforts. Dirt floors, common in older barns, become mud pits from animal urine and melting snow, creating damp conditions that make barns impossible to warm adequately. Modern Amish barns almost universally use concrete floors designed specifically for winter conditions. Concrete floors provide several advantages. They prevent urine from soaking into ground, instead allowing it to drain through proper floor slope to collection areas. They create a solid base for deep bedding systems, preventing bedding from mixing with dirt and reducing its insulation value. They also retain ground heat better than dirt, as the concrete mass absorbs warmth from below and radiates it slowly into the barn. Proper drainage design is critical. Floors slope gradually, typically 1 inch per 10 feet toward drainage channels. These channels collect liquids and direct them to lagoons or holding areas outside the barn. The drainage prevents puddles and standing water that would freeze, create slipping hazards, and raise humidity to unhealthy levels. Keeping floors dry means keeping barns warmer. Evaporating moisture draws heat from the air. Wet barn floors can make barns feel 10 degrees colder than dry floors at the same temperature. The investment in concrete flooring pays dividends every winter through improved warmth and animal health. Method 9. Closing off unused sections. Large barns contain more space than needed during winter, when animals spend maximum time indoors. Rather than heating entire barn volumes, Amish farmers close off unused sections, concentrating animals and heat in smaller areas that are easier to keep warm. Temporary walls of hay bales, wooden panels, or heavy tarps create barriers that separate used from unused barn sections. These barriers don't need to be airtight, they just need to block air movement and prevent heat from dissipating into empty spaces. The concentrated animal areas stay substantially warmer, while unused sections drop to near outside temperatures. This flexibility allows adjusting heated space based on animal numbers and severity of weather. During extreme cold, farmers might compress animals into even smaller areas temporarily, maximizing warmth. During moderate winter periods, barriers might be adjusted to provide more space while still maintaining adequate warmth. Spring brings removal of temporary barriers and reopening of full barn space. The flexibility of temporary walls allows this seasonal adjustment without permanent barn modifications. The practice demonstrates Amish preference for adaptable systems over fixed solutions. Method 10. Water system protection. Preventing frozen water represents one of winter's most challenging barn management tasks. Animals need constant water access. Cows drink 30 to 50 gallons daily, even in winter. Frozen water troughs or lines can kill animals within days from dehydration. Water lines get insulated where possible, buried below frost line depth, or wrapped with insulation material. Lines inside barns run along interior walls where animal heat provides some warming. Exposed pipes get checked multiple times daily during extreme cold and drained if freezing seems likely. Many Amish farmers use propane heated water tanks, one of few technologies they'll adopt because animal survival requires it. These tanks have propane burners beneath that prevent freezing without electricity. The propane expense is significant, but less than losing animals to dehydration. Some conservative communities still refuse these, instead breaking ice on water troughs 3 or 4 times daily, a labor-intensive solution that works but requires constant attention. Heated water also encourages animals to drink more, maintaining milk production during cold weather when cows naturally drink less. The slight warming from near freezing to perhaps 50 degrees makes enough difference in consumption to justify the propane expense through increased milk income. Amish barn warming methods demonstrate that effective climate control doesn't require electricity or expensive technology. Through strategic design, biological heat generation, natural insulation, and daily management, Amish farmers maintain barn conditions that support healthy animals and consistent productivity despite brutal winters. Modern farmers often dismiss these traditional methods as primitive or inefficient. Yet Amish dairy operations remain profitable without heating bills that can cost modern operations thousands of dollars monthly during winter. The initial labor investment, banking walls, stacking hay insulation, adjusting ventilation, gets offset by zero energy costs throughout winter.